wait for other. I'll let me know if I'm audible properly. Let me know if audible. We'll wait for some time for others to. Right. I think a few of you have joined, so let's actually get started with the problems. And so the first problem that we'll solve today, I think you already know about this, but this is called count inversions. Now, this is very important when it comes to interviews. Like, yes, Manav, please go ahead and ask your doubt. So this is very important for interviews. Like it's asked a lot in interviews like Microsoft, Amazon, and these, right? So this is important for you to know like what inversion count is and how can you find that. And not only that, right, you can actually also find inversion count on a dynamic array. So I'll not discuss about that in details, but once you actually I'll give you some pointers around how actually we can do that. Basically it's just like if you understand the definition of inversion count, right, a lot of things become very simpler. So Manav, please ask your question, like whatever doubt you have. So I'll wait for his question, and after that we'll start with this. Meanwhile, you can read this problem statement, like what is the problem statement exactly, and try to figure out like what is the meaning of counting inversions. Good. I'm thinking to purchase GFG interview preparation course, and I'm in second year. So is it good? I'm unable to remember the approach and code of practice. Okay. For the second question, Uday, we'll discuss today, and I hope that after that you get a like you understand what exactly is happening, so that you can remember. But for Manav, again, like I cannot tell anything, right? I myself don't have access to the course. I haven't seen that, so maybe you can ask someone who has purchased it, or you can look into like what people are saying about the course. So based on that you can make a decision, or you can try asking people like if how good is it or something. But I cannot make any comments on that because I myself don't have access to the content. Okay. So let's understand the problem statement again. So given an array of integers, find the inversion count of the array. What is inversion count? For an array, the inversion count is count indicates how far the array is from being sorted. If an array is already sorted, the inversion count is 0. If an array is sorted in reverse order, the inversion count is maximum. Formally, two elements ai and aj form an inversion if ai is greater than aj and I is less than j. So that basically means, what is inversion count exactly? Inversion count is how many pairs of elements are there such that there is ai, there is aj, I is coming before j, and ai is greater than aj. That means, let's say I have 1, 2, 4, 3. So if you see this pair 4, 3, they are actually forming an inversion, right? Because 4 is coming before 3. In simple words, how many, if we are talking about inversion count, what is exactly inversion count? In simple words, it is number of pairs such that a greater element is coming before a smaller element. Number of pairs such that a greater element is coming before a smaller element. So in this case, there is only one pair, so the inversion count is 1. Right? Let's take another example. Let's just modify this array a bit. Let's say we have an array like this: 1, 4, 3, 2. How many elements are there? How many pairs are there such that a greater element is coming before a lesser element? So 4, 3 is a pair, 1, 3, 2 is a pair, 1, 4, 2 is also a pair, right? 4 is coming before 2 plus 1. So 3. The inversion count for 4, 3, 2 will be 3. Okay. So that is basically the definition of inversion count. That is the definition of inversion count, right? How many elements are, how many greater elements are, how many pairs of elements are there such that a greater element is coming before a smaller element, right? That's the inversion count. So for example, let's take this 2, 4, 1, 3, 5, right? 2, 4, 1, 3, 5. So 2, 4, 1, 3, 5. What is the inversion count? 2, 4. Let's check all the pairs. 2, 4. Is 2, 4 an inversion? No. 2, 1 is an inversion. So 2, 1 plus 1. So this is because of 2, 1. Let's not write them. But again, like 2, 3 is an inversion? No. 2, 5? No, it is in order. 4, 1, 4, 1 is an inversion. 4, 3, 4, 3 is an inversion. 4, 5, 4, 5 is not an inversion. 1, 3. 1, 3 is not an inversion. 1, 5 is not an inversion. 3, 5 is not an inversion. 5 is not an inversion. So 3. The inversion count should be 3, I believe. Yes, it is 3. Right. So that is the inversion count. This is the definition of inversion count. Now, how can we find inversion count? A simple brute force algorithm will be run two loops I and j. Check if a of I is greater than a of j. Right. So the j loop will be running like this. I loop will run like this for I equals to 0, I less than n, I plus plus. J loop will run like this for j equals to I plus 1. So that j is on the right hand side, j less than n, j plus plus. And you can just check if a of I is less than greater than a of j. So basically you are fixing j to be on the right hand side of I, and you are seeing that a greater element is coming before a lesser element. So that will give a inversion, right? So you can do answer plus plus. So this is the brute force way, and the complexity will be order of n square, right? Complexity will be order of n square. How can we optimize this? How can we optimize this? Let's understand. Do you remember the merge sort operation? So we will revisit the merge sort operation entirely. So let's take this example only: 2, 4, 1, 3, 5. 2, 4, 1, 3, 5. But before we take this example, in merge sort operation, there was a method called merge, right? There was a method called merge that used to merge two sorted arrays. Right? In merge sort, there was a method called merge that used to merge two sorted arrays. So let's say the array elements are something like this: 1, 3, 4, 6. And here we have 2, 5. Here we have 2 to 5. 3, 4, 6, 2 to 5. So we have two sorted arrays and merge can basically merge them. Now, if you think about it carefully, when did we call the merge operation or how did we call the merge operation? We generally do something like this, that we in our merge sort operation, just think about it carefully again. We have a low to high and merge sort will sort this range low to high, right? So what we do is we find out the mid, low plus high by 2. We call merge sort on, we first sort the mid elements, low to mid. Then we call merge sort, we sort the mid plus 1 to high elements. Then we called merge on the first array, that is low to mid, and the second array is mid plus 1 to high, right? We called merge on these two elements. What does this mean? In the current state, in this current state, after left and right parts are sorted, after the left and right parts are sorted, we are calling merge on the first half and the second half. Now this is the first half, this is the first half, this is the second half. We will only count inversions at this level right now. What is the inversion that is remaining? That is, what is the cross inversion that is remaining, right? What is the cross inversion that is remaining? What do I mean by cross inversion? If you see, the first part is sorted, right? The first part is sorted, the second part is sorted. But in the second part, there are some elements that are less than the first part elements, right? So those will pair up to be an inversion, because the resultant array is 1, 3, 4, 6, 2, 2, 5, right? So they are indeed forming inversion, like this 4 and this 2. This is indeed forming an inversion. So we will just count the inversions here, that is there. That is the cross inversion between the first and second part. So what we'll do in the merge sort only, what we'll do is, what do we do when we merge into a single array? What do? We run two pointers, the first one here, the second one here. Now if ARR I less than ARR j, sorry, yes, ARR I is less than ARR j, in that case we'll add it, ARR I to this, and we'll do I plus plus. So 1 is added here. Next 3. Now ARR I is not less than ARR j, right? Now this actually gives the inversion. What is the inversion that is given? 2 is less than how many elements? 2 is coming on the right hand side. 2 is coming on the right hand side. It is less than these many elements. So that is how much? The total array size, let's call it n1 and let's call this n2. We'll do inversion count n1 minus I. N1 minus I will be these many elements, because N1 is the total size. Index I we are at. So it is less than these many elements. 2 is less than these many elements. So we will add this much to our answer. So answer plus equals to N1 minus I. That is how much? How many elements? 1, 2, 3. 3 elements, right? So we will add 3 to our answer. We will add 3 to our answer. Answer equals to 3. And we will add 2 here. Next we'll go plus plus. So 2 again. Now is ARR j less than ARR of I? Yes, again. So again this is less than 3 elements. 3, 4, 6. That is N1 minus I. So we will add this. We will add 3 to our answer. Plus 3. Plus. Now we'll go to the next element here. Is 5 less than 3? No. So we will see, we will not, this will not affect the answer, because this is not forming an inversion, right? 3 is coming before 5 only. So 3 will be added here. Next we'll go to 4. 4 is not forming an inversion, so we will add 4. We'll go to 6. Now 6, 5 is lesser, right? So 5 is forming an inversion with 6. So we will add, how many elements are left? 1. So 1 and 6, 5 is added here, and after that 6 will be added, right? So we have sorted this entire thing, and we have got the total inversion right now to be 3, 3, 6 plus 1, 7. If we see this array, the inversion right now is indeed 7. Let's see that. So 1, 3, 4, 6, 2, 2, 5. See the inversion. 3, 2, this 3 and this 2. Again we have another 3, 2, this 3 and this 2. That is the inversion. 4, 2 and 4, 2 again. 6, 2, 6, 2, 6, 5. See, there are 7 inversions in total, and we got 7. Right? So we will do that at every step, and eventually we'll find out the total number of inversions. Does this make sense? Let's actually draw the entire merge sort tree or merge sort operation to see like if it is indeed happening. So let's actually draw and find if we are getting the total number of inversions, right? So let's take an example. Let me see if there is a good example. Okay, 24135. 24135. So this will first call merge sort on the left half. So left half will be 2 4. The right half will be 135. This will in turn call merge sort on the left part, and on the right part 4. This will call merge sort on the left part, that is 1. Merge sort on the right part, that is 3, 5. This in turn will call merge sort on the left part 3, and merge sort on the right part, that is 5. Right. Now let's see. Let's come from here. We are merging these two. Now we are coming to the merge operation. We are merging these two together. So they are already in order. They are already in order. No inversion here. So we will return, our answer is 0 till now. So we have merged these two and we get 2 4 out of them, right? So we get 2 4 out of them. So this will return 2 4. We come to the right part. This becomes 1. This becomes 3 5. 3 5 becomes 3 and 5. 3 5 is broken down into 3 and 5. So 3 5, there is no inversion here. So this will be combined as 3 5 and it will return 3 5. And there is no inversion and this will return 1. So when we merge at this step 1 3 5, we are merging 1 and 3 5. There is no inversion here, right? So we will just return, will not add anything. We'll just return the sorted array 1 3 5. Now at this step, we have what? We have 2 4 as the left array, 1 3 5 as the right array. Let's do the merge operation here. So we start from here and we start another pointer here. So we see if this is greater than this, yes. So in that case, we'll do what? 1 will come here and we will add how much to the answer? Answer will be n minus I, that is 2 minus 0, that is 2. So 2 will be added to the answer. Because the inversion is 2 for 1, right? Because 2 and 4 are coming before 1 in the array. Right? 2 and 4 are coming before, come in the solution in Python. For Python, I think there should be something present already, right? I am mostly like, my focus here is mostly to explain you the algorithm, how it works. Then it can be definitely like be written in multiple solutions, be it C++, Java, Python, any. So with the interest of time, I will write in C++, but again, like I'm pretty sure, just try it on your end once with Python, and if you're unable to, just like maybe reach out to me. I'll definitely help you around that. All right. So 2 4, so 1 comes here. Now we will go to the next part, 3. 2 3. 2 is less, so it is already in order, right? So we will not do anything. We'll just add 2. We'll move ahead. Now 3 is lesser. So 3, there is an inversion. How many inversion? 1 inversion. So we'll add 1 to our answer and we will add 3 here. Now 5. Now 4 and 5, 4 is less. There is no inversion. So 4 comes here. After that 5 comes. So the total inversion count we get at this level is 3 and the total answer is indeed 3. Right? The total answer is indeed 3. Number of inversion count in this. So this is how we can find the inversion count. Does this make sense? How we are finding the inversion count? Anyone has any doubts? Anyone has any doubts with the inversion count? How we are finding it and why is it working? It's mostly on the merge operation, right? Like in the merge operation, this is the first, like this is coming before this one. This is the first mid elements. This is the next elements up to high. Now, if a element, let's say 2 is here and it is less than these many elements. So this is the inversion, right? Should have come before. So these many elements are greater than 2. So we should add that to our answer. So if we are doing it at every merge operation, then we are finding it for the entire array. Does this make sense? No doubt. All awesome. So let's write the code for this now. That might be a bit challenging. Let's try to write it. So we will have to write the merge sort entirely. Okay, so what every step will return is the inversion count at the merge, and we will have a long ARR, int low, int mid, int high. So this will help us merge from low to mid. So how do we do? We first create a temporary array with the size high minus low plus 1. High minus low plus 1. Good evening. High minus low plus 1. Okay. How do we do then? We maintain the pointers. So ptr1 is equals to low. ptr2 equals to mid plus 1. So while ptr1 less than equal to mid and ptr2 is less than equal to high. Okay, and also we maintain the inversion count here. Inversion count equals to 0. So if ARR of low, sorry, if ARR of ptr1 is greater than ARR of ptr2, right? If ARR of ptr1 is greater than ARR of ptr2, then what do? We do temp of ptr2, temp of, sorry, and also for populating on the temp array, we'll need another variable called pos. Position equals to 0. So temp of pos plus plus equals to ARR ptr2 plus plus. This is what we do in the merge sort. But other than that, we will also add to the inversion count here, right? Because on the right hand side, we have a smaller element, so that will give us inversions, right? So inversion count plus equals to how many? It will be mid minus whatever is ptr1 at plus 1. So these many inversions will be there. Else it's normal, it's not an inversion. So temp of plus equals to ARR ptr1, right? ARR ptr1 plus plus. Now while ptr1 less than equal to mid, temp of pos plus plus equals to ARR ptr1 plus plus. While ptr2 less than equal to high, this is standard merge operation, right? Temp of pos plus plus equals to ARR ptr2 plus plus. And finally, for int I equals to 0, I less than pos I plus plus, we will copy back into the actual array. So ARR I plus the starting point is low equals to temp of I, right? So this is the merge operation, and we'll finally return the number of inversion counts that we have seen. So number of inversion count is return inversion. Okay. Now we will write the merge sort. So long merge sort, again that should also return the inversion count. So we will have the array here. Okay, this should be long ARR int low int high. If low greater than equal to high, return 0. Otherwise what we'll do inversion. So int mid equals to low plus high by 2, and we'll call long count. Let's maintain the count here. Count equals to merge sort ARR low to mid. We have whatever is the inversion count from low to mid, that will be returned from here. Similarly, inversion count plus equals to whatever is the inversion count from mid plus 1 to high, that will be returned from here. So mid plus 1 to high, we are sorting it and we are also finding the inversion count. Now what is the current inversion count? That is, what is the cross inversion count between low to high? Low to mid is sorted, mid plus 1 to high is sorted. So what is the inversion count from mid plus 1, low to mid plus mid, and mid plus 1 to high between them? That is given by the merge operation. So that we will have to inculcate as well. Inversion count plus equals to merge ARR low, mid, high. Return inversion count, right? And finally, what we can do here is we can just return merge sort ARR 0 to n minus 1. So that will find the total number of inversion count. We are sorting the entire array. Compilation error while PTR1 less than equal to mid and PTR2 less than equal to, is it expecting? Fine, right? I long temp high minus 1 while PTR1 is PTR2 have this inversion count, while PTR1 less than equal to mid and PTR2 less than equal to high. What is problematic? Expected. Okay. Oh, we are running in. Sorry, let me just copy everything. Let's write everything here again. Oh, here we have to dot ARR to if this is ARR low. We are calling merge dot here with this. That. Okay, our output is expected, so let's submit it. So is this clear with everyone? Any doubts with this? How is this working? Yeah. Yes, right. Is this clear? Clear with everyone? How is this working? Like we are first finding whatever, like the merge operation will find what is the inversion count between the mid and the high, the first half and the second half, and merge sort will basically recursively calculate the inversion count in the first half. We will add to that inversion count in the second half, and then we'll add the inversion count between the first half and the second half. So we are adding to that. That's why this will return inversion count in the first half. This will return inversion count in the second half. This will return inversion count between the first and second half, and then we'll return the final inversion count between both. That's basically the idea. Is this clear with everyone? Then we can move to the next problem, which is also very, very important when it comes to So let's start with this problem now. Now this is very, very important when it comes to interviews. The problem is trapping rainwater, right? So very common question. Given an array of n non-negative integers representing the heights of the blocks, if the width of the block is 1, compute how much water can be trapped between the blocks during rainy season, right? So you are given an array of n non-negative integers that represents the height of the block. The width of each block is 1 unit. What is the total amount of rain that can be contained during a rainy season? That is the question. What do we mean by containing the rain? Let's understand. So here if you see, this much amount of rain can be contained, right? So this is the amount of rain that can be contained within the blocks that is given by this, right? So this is the amount of rain that can be contained. Now to understand this more specifically, like what exactly this does, what exactly this is happening, so let's understand this properly. So let's take a different example. Let's say it's something like that. Something like this, right? So what is the amount of rain that you can store? uh, we can store rain, right? But what we'll do is, for every block, instead of directly trying to find what is the total amount of rain we can store, for every block we will try to find what is the amount of rain that we can store on top of that block, right? Can we store, for the first block, can we store any rain on top of this here? No, right? Because whatever rain is stored here, it will overflow this side. It will overflow this side. So this will not store any rain. This will not store any rain. Again, for this block, can we store anything on top of this? No, because anything we store will overflow this side. So we cannot store any rain on top of this. For this block, can we store any rain? We can store rain. How much rain we can store? So there are two possible ways of escape, right? There are two possible routes of escaping. That is the left side and from the right side. So how much rain we can store? We can only store up to this much amount of rain. Because if we store more than this, it will escape from the left hand side. So we can only store this much amount of rain. For this block, how much rain we can store on top of this? We can again store this much amount of rain. For this one, how much rain we can store? Whatever rain we store on top of this, we'll get out from in this side, right? So we cannot store any rain. For this, again, we cannot store any rain. It will escape from either side. For this one, we can store this much amount of rain, because if we store anything more than this, it will escape from the right side. For this one, we cannot store. For this one, we cannot store. So this is the total amount of rain that we can store. This is the total amount of rain that we can store. Now let's formally define what is the amount of rain that we can store for any, on top of any building. Let's say we are on building I. Let's say we are on building I. We are on building I. What is the amount of rain that we can store on top of building I? Can you tell what is the amount of rain we can store? What is blocking the rain? What is blocking the rain? The rain is being blocked by some block on the left hand side. Similarly, on the right hand side, it is blocked by some block on the right hand side. Which will block the rain? What will block the rain? It will be the maximum height building on the left hand side, right? Let's say I have a very huge building on the left hand side like this. So this will block all the rain on the left hand side. Similarly, if I have a huge building on the right hand side, it will block all the rain on the right hand side. So what is the maximum block size on the left hand side? That will block the rain. Similarly, on the right hand side, what is the maximum block size on the right hand side? That will block the rain. So it will be, what is the amount of we can store? It will be max of left max of I. What is the maximum block of left on the left side? Sorry, the minimum of, because we can store only the minimum of, just consider this building as example. Here the right maximum is this much, but we cannot store this much water, right? Because it will overflow this side. So the minimum of left max side right max of I minus the height of I, minimum of left max I, right max I, so minus height of I, that is the amount of water that we can store. And this is the exact solution for the problem. So what we'll do, we will, how we can find the left max and the right max? Prefix max, we can use prefix max. So how do we do prefix max? If you don't know already, left max of I, we can write it as maximum of either whatever is the maximum till I minus 1, whatever is the maximum till I minus 1, that is left max I minus 1, or A of I, whatever is maximum, that will be the left max of I. Similarly, right of max of I will also be defined like that. Right max of I is max of right max of I plus 1 on the right hand side, comma A of I, whatever is the maximum till I plus 1, or A of I, that will be the right max. So we can compute the left max and right max for all the buildings using prefix and suffix maximums, and then we can use this formula to, we can do answer plus equals to for all the buildings, right? So this will be, what is the complexity involved? Order of n time complexity, order of n space complexity. Anyone has any doubts with this solution? After this, we'll try to optimize this a bit more, but any doubts with this solution? I believe that you understand what is left max. It will store the maximum on the left hand side till I. Similarly, right max is what is the maximum till I on the right hand side. So if we take an example here, let's take an example here. Let me know if this is clear with you, and we'll also do an example here as well. So 300 300 4. Okay. What is left max? 3 at index 1. It will be the maximum till index 1, right? So what is the maximum till index 1? 3 only. Again 3, 2, sorry, 3, it will remain 3, it will remain 3. Here it will become 4. This is left max. What is the right max? We will compute from the right hand side. So it will be 4, 4, 4, 4, 4, 4. Everything will be 4. What is the amount of water that can be stored per building? For this one, for the first one, it will be 0. For the second one, minimum of left max, right max, it is 3 minus building of height, that is 0, that is 3 units of water. For the third one, again, minimum of 3, 4 minus 0, that is 3 again. For the fourth one, minimum of 3 and 4, that is 3 minus 2, that is 1. 1 unit water can be stored. 3 and 4 minus 0, again 3, and again 0. So this much amount of water can be stored. So that is 3 plus 3, 6, 9 plus 1, 10. 10 units of water can be stored, and it is indeed 10 units of water that we can store. So this is the logic for solving the problem. Let's actually optimize this a bit. We'll try to optimize, although this is accepted. Like if you see, the space complexity expected is order of n. So we can definitely do this, but we will do it further. We'll do it a bit better. We'll use 2 pointers to solve this, right? So this can also be solved using 2 pointers in order of 1 space complexity. Let's understand that. So and the code will be homework. I'll write the prefix max, suffix max code, but the code for 2-point approach will be home, right? So let's actually take an example, a good example maybe. Let's say 240 5 5 1 3. Let's say this is this is the array, right? This is the array. let's say this is the array. What can we do here? 3 1 6 2 5 4. Now we'll maintain two pointers, right? We'll maintain two pointers, one on the left, one on the right. And what we'll do is we'll also maintain two values. Left max, what is the maximum on the left that we have seen till now? That is 0. And right max, what is the maximum on the right that we have seen? Now we'll first check if the first pointer a of ptr1, if it is less than the value that is pointed by the second pointer. 2 is less than 3, right? 2 is less than 3, and also we have answer equals to 0. 2 is less than 3, right? So we will check this with left max. Left max is 0 right now. Left max is 0 right now. So that means we cannot store any water on top of this. So we will just update the left max to 2 and we will do ptr1 plus plus. Next we come to 4. Again we'll do the same thing. Is ARR of ptr1 less than ARR of ptr2? No, right? Here it is not less than. So we will move now ptr2. When we move ptr2, we'll see the right max. Right max is what? Right max is right now 0. Right max is 0 right now, so it cannot store any water as well. So we will do ptr2 minus minus. We'll do ptr2 minus minus. Come to this. Now we'll again check is, and also we'll update the right max to. We update the right max to. Now, what do we have here? ARR of ptr1, that is 4, is less than equal to ARR of ptr2, right? It is less than, definitely. Sorry, it is greater than. So we will move ptr2. So what we'll check here is we'll check the right max. What is the right max? The right max is 3. So we can tell that we can store the amount of water that is equals to 3 minus 1, that is 2 units. Why can we store this much water? Just let's understand this. We have only crossed this one, right? We have only crossed this one. We have only crossed this one because there is a value that is greater on the left hand side. There is a value that is greater on the left hand side. That's why we have crossed this one. If there was no value greater than 3 on the left hand side, then we would not have crossed 3, right? We would not have crossed 3. So that's why we know that definitely on the left hand side, we can store up to 3 units, maybe more. But on the right hand side, we cannot store more than 3 units. So we'll add 3 minus 1, that is 2 units of water we can store here. We will not update the right max because it is not updating. We'll go ahead. We'll come to 6. Now ARR 4 is less than ARR 6. So we'll check with left max. Is it less than left max? No, it is not less than left max. So it will not store any water, but we'll update the left max to 4. Now we will move ahead. Okay, 0. Now for 0, we will only see the left max. Why will we only see the left max? Because we are very sure as the left max is 4, the right maximum that we have seen till now, or whatever is here, that is definitely greater than the left maximum. That's why we have crossed the left maximum, right? That's why we have crossed this left maximum. Otherwise, we would have only been we would have not crossed the left maximum. We would have only moved the right pointer. So we will see here that 4 is there and 0 is there. So it can store 4 minus 0, that is 4 units of water. And we will go ahead. Will not update left max. 5. 5 is greater or 6 is greater? 5 is lesser. We will move 5. But can we store water? Left max is less than 5. So we cannot store any water. So we will just update this to 5. And we will move ahead. We'll come to 2. 2 is less. Now, which side will we store 2? 2 will be stored on the left max side because left max is moving. So definitely there is something on the right hand side that is greater than the left max. That's why the left max pointer left pointer has moved, right? The left pointer has moved. So we'll compare with 5. 2 minus 5, 5 minus 2, that is 3. So 3 units of water. And we will cross other. So once we reach same point, we will just exit, and the total amount of water we can store is 4 plus 3, 7 plus 2, 9 units. So this is how we can do it using a two-pointer approach. The idea being that if you look into this carefully, we cannot cross a pointer against a value if there is nothing on the right hand side that is greater than this one. Only when it is greater than this one, then only we can cross this 4 and go ahead, because we had come to 6. Otherwise we would have moved the right pointer. Same logic goes to the right pointer as well. On the right pointer, when we move the right pointer, we just compare with the right max, not the left max, because the right max will be limiting us there. So this is the logic. We'll write the order of n code only. This will be for your homework. How can you do it in order of one space complexity, right? So how do we do this in order of n? We'll maintain the two things. F max of 0 equals to ARR 0 for in I equals to I less than I plus plus. F max of I is equals to max of F max of I minus 1. ARR I. Right max for int I equals I greater than equal to 0, I minus minus. We'll find the right max of I is max of right max of I plus 1, and int answer equals to 0 for int I equals to 1, I less than 0 and n minus 1 cannot store anything, so 1 to n minus 1 answer plus equals to min of left max of I, right max of I minus, and finally we can return answer. So it can be long actually. Let's have long. Let's try to run this. Try doing it on order. Try doing it in order of 1. I explained the logic. Try doing it. Left max is, let's have this, I believe. Left max was not declared in this scope. Left max will typecast this to typecast this. So we have solved both the problems today. Let me know if you have any doubts. But we can go through the homework questions. Now, for first homework is this one. Like, try to do this in order of 1 space complexity, like I discussed, using a two-pointer approach, and try understanding why it is working. Second question that we have is wave array. It's a easy problem. So you are given a sorted array of distinct integers. Sort the array into wave-like structure. That is, ARR1 is greater than equal to ARR2, less than equal to ARR3, like this. It is also pretty simple problem, and you have to do it in order of 1 space complexity. So just try to do this. Second problem is remove duplicates from an unsorted linked list. So you are given an unsorted linked list of n nodes. You have to remove the duplicate elements that are there in the unsorted linked list. So You can use order of n space as well, order of n time. It is also pretty simple question. Finally, you have to find the missing and find missing and repeating element. So given an unsorted array ARR of n integers, one number A from the set is missing and one number B is occurring twice in the array. Find these two numbers. This is also pretty simple question, right? So you have to do this. Order of one space. So these are the questions for your homework. So try to complete these, and I hope that the questions that we discussed today are clear, very clear to you. Make sure to do the trapping rainwater order of one space complexity question. This is very important from interview point of view. All right. I'll be seeing you in the next class, that is Wednesday. So thank you guys for joining in.